Voltage drop? Why would you want to do a voltage drop? Can't I just check continuity? Yes, you can just check continuity or check resistance. The problem is the circuit is not loaded. The reason why we always teach you guys to do a voltage drop test is a voltage drop test is checking the circuit for resistance in a dynamic state, which means we have current flowing through the circuit. So that's when we're actually testing it. I always mention it's kind of like a stress test. You're stressing the circuit to see if the circuit has the capability of actually sustaining a load. This is why voltage drop testing is super important for us as diagnosticians. What I'm going to show you guys today is first, we're going to set up our bench power supply with a circuit. We're going to measure to see how much current draw and everything we have in the circuit. Then I'm going to add some resistance. So this way you guys could see how the resistance affects the voltage drop in the actual circuit. So go ahead and grab your voltmeters, guys. Let's get ready. Let's hit it. In the past, I've been asked, what is a voltage drop test? What I have set up here is I have my power supply at 12 volts and it's putting out 2.083 amps and it's powering a light bulb. What I'm going to do right now is I'm going to take a voltage measurement from my voltage output to the input of the bulb and then ground to the output. So this way you guys could see what a known good looks like. Then I'm going to use my decade box and add resistance and do the same voltage drop. Let's take a look. With my meter set into volts DC and my two leads connected as if I'm going to do voltage, I'm going to take one lead to the power output of my power supply and the other lead to the input side of the actual voltage drop on this one is 54 millivolts. Usually on a power, you want to see no more than 300 millivolts. Now let's go ahead and test the ground side. And on the ground side, I'm on the ground side of my power supply and the ground side of the bulb, and I'm getting 64 millivolts. Again, this is a good indication that we have current flow and we actually don't have much resistance within that circuit. Now I'm going to go ahead and add some resistance using the decade box, and then we're going to recheck. All right, so I got my decade box in circuit. Right now we're at 12.69 volts and we're drawing about 1.9 or 2 amps. So we're going to go from the power output of my power supply to the power side of my bulb. Now if you notice, before we were roughly about 50 millivolts, now we're at 1.0 volts. Okay, so we're already indicating that we have more voltage drop between the output side of the power supply and the input side on the power side of the actual bulb. Now let's go ahead and add 3 ohms of resistance and let's see how all of that changes. So I've added 3 ohms of resistance. If you notice, my voltmeter is now showing 4.6 volts and climbing. And also my power supply now is showing 1.5 amps. So it's drawing less current, right? Why? Because now we have an excessive voltage drop or adding resistance to that particular circuit. Now let me go ahead and add 4 ohms of resistance and let's see how it changes. So I'm adding 4 ohms of resistance here and I got 6.3 volts on my meter for voltage drop. And now I'm only drawing 1.4 amps. So remember, if resistance goes up, amperage goes down. And that's exactly what we're seeing here on my voltage power supply. Now let's go ahead and test the ground sides and see how they act. Keeping in mind I have the decade box on the power side, 3 ohms of resistance added on the decade box. Notice how my voltage drop doesn't really change on the ground side. What did change was my amperage. Now why didn't it change? Well, that's indicating the resistance is actually where? On the power side of the circuit, not the ground side. So let me go ahead and add 4 ohms of resistance. You guys can see the bulb gets dimmer. My amperage draw drops, but my voltage drop kind of remains the same. We're at 44 millivolts here, right? And again, notice how my voltage drop has dropped. So again, this has confirmed to me that the problem is not on the power side, it's going to be on the ground side of the actual circuit. I hope this information was super helpful to you guys because voltage drop testing is the best way to check for unwanted resistance in an electrical circuit. Go ahead and drop in the comments and let me know what you think about voltage drop testing, or are you going to continue testing for resistance? This is Oscar Gomez from Master Automotive Training. I'll see you guys on the next one.